Factor the trinomial completely. 18m cubed minus 24m squared plus 8m. First of all, recall that factoring is doing multiplication in reverse. Our trinomial contains three terms where the terms are being subtracted and added. Our goal is to find polynomials that when multiplied together will give us this trinomial. So first of all, we want to look for the greatest common factor. Notice that each of the coefficients is divisible by 2. Each of them is even. Notice also that each term contains a factor of m. So let's go ahead and factor each of the terms to determine the greatest common factor. We'll start off with 18m cubed. 18 is even, so it's divisible by 2, so we'll write down 2 first. And we know that 2 times 9 is equal to 18, and 9 is 3 times 3. And also recall that m cubed means that m is being multiplied 3 times. M times m times m. Next, factor minus 24m squared. The negative coefficient indicates that negative 1 is a factor. 24 is even, so it's divisible by 2. And 2 goes into 24 12 times. 12 is even, so it's divisible by 2. And 2 goes into 12 6 times. And 6 is divisible by 2. And 6 divided by 2 is equal to 3. M squared is m times m. The last term is 8m. 8 is even, so it's divisible by 2. And 8 divided by 2 is 4. And we know that 4 is 2 times 2. And then we have one factor of m. So what we do next is we identify the greatest common factor. So we look for factors that each of the terms have in common. Each of the terms has a factor of 2. Now the second two terms have another factor of 2, but the first one doesn't. And so 2 is the largest factor that we have for the coefficients. Then we look for our variable factor, or common factor, and we see that each has a factor of m. And although the first and second terms have more factors of m, the third one doesn't, and so m is the largest variable factor. So what is our greatest common factor? Well, the greatest common factor is 2 times m, because each of the terms has that as a factor. So we'll indicate that our greatest common factor, which we'll abbreviate as GCF, the greatest common factor is equal to 2 times m. So at this point we'll factor out the greatest common factor. So we put 2m and then a set of parentheses. The parentheses indicate multiplication. And so since our trinomial has 3 terms in it, we need to make sure that we have 3 terms inside the parentheses. In order to get each of the 3 terms, we just look at the remaining factors in our factorization of the terms. So for 18m cubed, the remaining factors are 3, 3, m, and m. When we multiply those together, we get 9m squared. For minus 24m squared, our remaining factors are negative 1, 2, 2, 3, and m. When we multiply those together, we end up with minus 12m. And for the last term, our remaining factors are 2 and 2. When we multiply those together, we end up with plus 4. So the first step was to factor out the greatest common factor. Now at this point we have a trinomial remaining inside the parentheses. We need to try and factor that trinomial. One technique is to just factor it using the FOIL method in reverse. You guess the binomial factors and then you test by using the foiling method. If that works for you, great. If not, then there's a more systematic method called the AC method. Just identify the A, the B, and the C. The A in this case is 9. The B is negative 12. And the C is equal to 4. So the technique says, first of all, find AC. A times C is equal to 9 times 4, which is 36. Now once we find AC, then we want to think of two numbers that multiply together to 36 and add together to our B term. So we want to make sure that we take 36 and we're trying to think of two numbers. Let's call them M and N. So two numbers, M and N, that multiply together to 36 and that when added together add up to our B term. So our B term is negative 12. And we want to make sure that the two numbers add up to negative 12. So if we take a systematic approach to this, we would have M, N, and M plus N. And we want the two terms to add up to a negative number, and when multiplied together we want the result to be positive. So that means that our two numbers have to be negative. So we might start off with negative 1. We know that 36 is divisible by negative 1. And when we divide 36 by negative 1, we end up with negative 36. But when we add negative 1 and negative 36 together, we get negative 37, which is not equal to negative 12. 36 is even, so it's divisible by negative 2. But 36 divided by negative 2 is negative 18. And when we add these two numbers together, we get negative 20. 3 plus 6 is 9. 9 is divisible by 3, so that means that 36 is also divisible by 3. So let's let M be negative 3. Negative 3 goes into 36 negative 12 times. And when we add negative 3 and negative 12 together, we get negative 15. Now notice that our sums are getting closer to negative 12, so we're on the right track. Let's try negative 4. Negative 4 goes into 36 negative 9 times. When we add those two together, we get negative 13. And then finally, 5 doesn't go in, but 6 does. So if we use negative 6, then negative 6 goes into 36 negative 6 times. And when we add those two together, we get negative 12. So this one checks out. When M is negative 6 and N is negative 6, then the sum is negative 12. So what we do is we go back and we replace the negative 12M with negative 6M minus 6M. So we use the M and the N to replace the B. So we have 2M, and then we'll leave the 9M squared. But in place of minus 12M, we're going to put minus 6M minus 6M. And then we'll leave the constant term the same. Now at this point you use the technique of grouping. So what we're going to do is to group the first two terms and group the last two terms. So we have 2m, and I'm going to use a set of brackets now. So we look at 9m squared minus 6m, and we determine what is the greatest common factor of just those two terms. Well, 3 divides evenly into 9 and 6, and m divides evenly into each term. So the greatest common factor is 3m. So we'll factor out 3m, put a set of parentheses, and inside that parentheses we need two terms. When we take 9m squared and divide by 3m, we get 3m. When we divide minus 6m by 3m, we get minus 2. Alright, we look next at 6m and 4, and we notice that 2 goes into both 6 and 4, and that is our largest factor. Now in front of the 6 we have subtraction, so we want to make sure that we actually factor out a minus 2. Put a set of parentheses, and inside that parentheses put the remaining factors. When we take minus 6m and divide by minus 2, we end up with 3m. And when we take 4 and divide by negative 2, we get minus 2. Now, at first glance, it may seem like we're making things more complicated, but what we want to recognize now is that we have two terms, and each of those two terms has a common factor of 3m minus 2. So we're going to factor out the 3m minus 2. So we have 2m, and then we pull out the 3m minus 2, and there are two terms, so we'll put a set of parentheses, and inside of that parentheses we need to put two terms. For the first term, we'll put the coefficient of 3m minus 2, which is 3m. And for the second term, we'll use our second coefficient, which is minus 2. So now we've completely factored. We would probably write it as 2m. And then we have two factors of 3m minus 2. So we would write 3m minus 2 squared. When we square a factor, it means that we have repeated multiplication. So our complete factorization is 2m multiplied by the square of 3m minus 2.